Welcome back, all my aspiring mathematicians. Today I'm going to discuss a topic in pre-calculus that has to do with optimization of a volume. What does it mean by optimization of volume? We are looking for the maximum amount of volume that container can hold. And we're going to talk about a box. Since we're talking about the optimization of volume, when we are dealing with volume, we have to deal with 3 dimensions. We have to deal with the length, the width, and the height. The first thing that I would advise you to do is to draw a sketch of what the problem is asking you to. I'm going to show you the simplest way of arriving at your answer using derivative. So let's get into it. So it says that an open box is made from a 3-foot by 8-foot piece of sheet metal by cutting out squares of equal size from the 4 corners and bending out the sides. We're asked to find the maximum volume. So let's first do a sketch. We have our 8 feet here, and this side is going to be 3 feet. All right, this is what we are going to have. We are going to cut out corners. All right, if I cut out corners here, let's label that as X. I'm going to also label this corner here as X. I'm going to label this one as X that I'm going to cut out, and I'm going to cut this one. Let's get right into it. So because I have my dimension there and I have my 4 corners taken out, now I can simply say that this side is simply going to be not just what you are seeing here, but it's going to be 3 minus 2x, and this will be 8 minus 2x. Same thing for the top piece, same thing for the side here is 3 minus 2x. We're going to fold up the sides of the box. This is what the sheet metal would look like when you cut out the 4 corners. I need to now fold these corners in, and I'm going to do it for all 4 corners. This is what the open box would look like after you have folded in all the 4 corners. This box is in the shape of a rectangle, and you have the length, which is 8 feet, and the width, which is 3 feet. Since you have the length and the width, we now need to find the height, which is X. That will help us to determine the maximum volume that this container can hold. We are going to write what is. So we know that volume is going to be length times width times our height is going to length, which is going to be our 8 minus 2x, and our width is going to be 3 minus 2x, and we have x as our height. The first thing that you need to do here, you are going to expand all these 3 terms out. So we will get v is equal to 8 times 3 is equals to 24. And 8 times negative 2x is going to be negative 16x. And negative 2 times 3 is going to be negative 6x. And negative 2x times negative 2x is going to be positive 4x squared. And we must rewrite the x there. Next thing we must do is that we must combine our like terms. So we will end up with v equal 24 minus 22x plus 4x squared. And then we have the x here. I now want to bring this x on this side, and I want to rearrange the trinomial here in the standard form. So v equal x positive 4x squared minus 22x plus 24. The next step is that I am going to expand this, and I will get v equal 4x to the 3rd power minus 22x to the 2nd power plus 24x. Find the derivative of this. All right. I am going to take the derivative. You're taking the exponent, multiplying it by the coefficient, which is going to be 12, and we have our x, and we are going to reduce the exponent by 1, so we have 12x squared. We are going to multiply the 2 by the negative 22, so that would be negative 44, and it will be x. Because we reduce this, we are not going to put the 1 here, and we will just have 24. So this is the derivative of what we have. We're going to look back at the dimensions that we have. Here is 3 feet, so we are going to divide that by 2, which is going to be 1.5 foot. So that 1.5, the domain, we can write our domain is going to be fall in the range of 0 is less than x less than 1.5, or I can write 3/2. We're looking for anything that is going to be less than 3/2 when we are writing it. So our x value, we are going to look for that. Now the next step that we need to do is that we are going to use our quadratic formula and we're going to find the value for x. So we are going to use x is going to be equal to negative b plus or minus square root of b squared minus 4ac, and all of that is going to be over 2. And that is our quadratic formula. Yes, I know we are going to plug in numbers and we are going to look at the derivative here. We're going to identify our a. 12 is going to be your a. The b is going to be negative 44. This is going to be your b, and this is going to be your c. So we're going to plug this into the formula there. Let's plug these numbers in. So we now have x is going to be equals to negative, b is already negative, you must substitute it properly, plus or minus the square root of b squared. So we're going to do negative 44 square minus, it's going to be a positive number, don't worry about that, minus 4 times a, which is 12, and our c value is 24 here. And that is all going to be over 2 times a, which is 12. Off the top, we know this is going to be a plus, so we have x is equals to 44 plus or minus the square root. Negative 44 times negative 44 is going to be 1936. Negative 4 times 12 is going to be negative 48, times 24 is going to be negative 1152. And that is going to be over 24. So we're going to do the math now. So x is going to be equals to 44 plus or minus the square root of 1152 from 1936 is going to be 784. And that is going to be divided by 24. We're not done. So the square root of 784, we know that that is going to be 28. So x is going to be 44 plus or minus 28 over 24. So what we need to do now is that we need to separate these. So we have x is going to be equal to 44 plus 28 over 24, or x is going to be equals to 44 minus 28 over 24. So x is going to be equals to 72 divided by 24, which is going to be, x is going to be, I'm going to write over here, x is going to be equals to 3. And for this one, x is going to be 44 minus 28 is simply going to be, carry the 1 over here. 8 from 14 is going to be 6, so 16 over 24. So 16 over 24 is going to be 2/3. All right, so 2/3. Looking at your domain, right, you cannot choose x equals 3. No, you can't do that, because that does not fall into your domain. It is going to fall between, so you cannot choose this one, so you have to end up choosing this one, so x is equals to 2/3. So this is the one that we need to choose. All right, so we're going to take that now, and we are going to now substitute this value for x into our original equation. Now that I have my value here for x, I'm going to substitute it into the original equation, but I'm going to rewrite our original equation with the x in front. So I'm going to rewrite that, and I'm going to have x parentheses 8 minus 2x close parentheses 3 minus 2x here. So I'm going to substitute 2/3. I know a lot of you don't like working with fractions, but you need to get used to it, okay? So I'm going to have my 8 minus 2, and my parentheses there is 2/3. And then I'm going to have my 3 minus 2, and my parentheses there is going to be 2/3. All right, so I'm going to do the math now. Let's do the math. A lot of you out there are suffering with fraction phobias, but guess what? I'm here to help you to overcome that phobia with fractions. So let's get into this. All right, so now I'm going to do what I have in the parentheses here. So I'm going to have my 2/3 times 8 minus 2 times 2/3. What I'm going to do, you're going to rewrite that as 2/1, make your life easier. It's going to be 4/3. And for the other one, it's going to be 3 minus, we put over 1. That's this way you're multiplying across. I'm showing you what to do. I know how to do it fast, but I have to show it to you. This is 4/3. All right. We need to now change this 8 into a fraction where you have 3 as the denominator. So 8 times 3 is 24. So we're going to have 24/3. And here we end up with 9/3. So we change that to the common denominator that we would have. So minus all 4/3. And we have our 2/3 here. Always write your V equal. And this is your 3 minus 4/3. This will make your life easier, okay? So now you have 24/3 minus 4/3. That's going to be 20/3. And you are going to have 9/3 minus 4/3, which will be 5/3. Wow, see? It's not that bad, folks. You just have to know that when you're multiplying a whole number with a fraction, just write it as a fraction first and then multiply it across. It's easy, just like that. It's not hard, all right? Now we are going to multiply. We can multiply these two first, right? So I'm going to have my 2/3 here. I need some space. I'm going to do it over here. Okay? I need some space. So I'll have V equals 2/3 times 100/9. Then we're going to multiply now. So V is going to be 200/27. Haha. 200/27. You can break this down, or you can use decimal. So 200 divided by 27, you know that it's going to be less than 10 because it would have been 270. I already know that it's going to be 7 because 7 times 27 is going to be 189. So 189, you're going to be left with 11. So 11/27. So we have the fraction here, but we don't want to give our answer as a fraction when we're talking about volume, all right? So we need to give it as decimal. So we know that this is going to be equivalent to V is going to be 7.407. And because we're dealing with volume and because our unit measure there is feet, it's going to be in cubic feet. So that is going to be our volume. Because it is a word problem, you must write your answer in a word form. So the question asks you, find the maximum volume. So you're going to simply write that the maximum volume is, and you can write approximately 7.40 cubic feet. All right, that's what the maximum volume is. I hope that this video has helped you tremendously, and now you are able to do any math problem that deals with optimizing volume. And I also hope that you were able to understand how to work with multiplying with fractions. Thank you for watching. Please like, subscribe, and share my videos with others around the world so they too can learn about math. And this is a topic on pre-calculus. Thank you. Bye now. Cheers.